In this video of Let's Talk Math, we're going to learn how to solve a system of linear equations by graphing. So first, before we can do that, we need to know what a system of linear equations is. A system of linear equations is usually when you have two equations that represent the same situation. Now let's do a little review of what a linear equation is. So a linear equation is when you graph it, it forms a straight line. So for example, this line could be a linear equation. This line could be a linear equation. So could this line be, and this line. These lines are all linear equations because they are straight. But there are some linear equation lines like that could graph isn't not a linear equation. Like this would not be a linear equation, and neither would be if I graph this. These are both not linear equations because they do not form a straight line, right? So this and this. Now, next is a linear equation only has one or two variables. So that could be like y equals 3, x equals negative, 6, y minus x equals positive 5, right? These are all good examples of having one or two variables. A linear equation could not be like, let's say, 3 equals x minus y minus z. It has three variables instead of 2 or 1. So this does not count. Now, it says, the last part, it says it has variable needs to only have the power of 1. So let's say x plus y will equal 3. Well, this has the power of 1 even though we don't see it, right? X or y equals 4. This still has the power of 1. 2y plus 5x equals 10. This still has a power of 1, so it still counts, right? So these are all linear equations. Now, instead, let's say I have x to the power of 2 plus y to the power of 3 equals, 125. This will not count as a linear equation because the variables have a power, x has a power of 2 and y has a power of 3, right? Which is not a power of 1, clearly. Now, another thing would be 1 over x equals 3. See, when you have a variable as a denominator, this will also equal x to the power of negative 1. So this will not count either. So, let's just do a quick example real quick where we need to write a system of linear equations where the perimeter is 18, right? And this length is twice the width. So this is the width and length. So to find the perimeter, that'd be 2L plus 2 of the width, which would equal 18. And then it says 2 of the width would equal the length. Now, to find the length and width, right? What we would need to do is we need to find what the width and length would be to solve both of these. And this counts as a system of linear equations because they both represent the same rectangle. But let's say this represented this one, but let's say this represented a rectangle like this, right? This would not count, but instead it does, and since it represents the same rectangle, it counts as a system of linear equations. Now, Now, to find the solution, we need to find something that works with both of the equations. So, for example, we could have 2, which equals 4, right? And this would be the width, this would be the length. But if we wrote it in this equation here, that'd be that would be 8 plus 4, and that would equal 12, which does not equal 18. So they both may have infinite solutions, but there's only one solution for both of these. So 2 times 3, right, equals 6. This being the length and this being the width. Now this would work because 2 times 6 plus 2 times 3 equals 18. So the width is 3 and the length is 6. Now, going further into the solution of a system of linear equations. A solution for a system of linear equations is when you have a ordered pair that satisfies all of the linear equations. So if to find the solution by graphing, if we were to graph those two equations, right? But I'm going to just draw two different lines. It does not do with those two equations that we have just written, right? They both, each line individually has infinite amount of solutions. But for the system of linear equations, which would be what these two are, there's only one solution, and that is where the line intersects, right? Which is right here. So where the lines intersect is the solution. So to find a solution of a system of linear equations, first you graph it, and then if you look where they intersect, and that is the solution. Now we're going to do a few examples where we are given the system of linear equations and we need to find the solution of the system of linear equations by graphing. Now here we have y equals 2x minus 5 and y equals 1/3 of x. First I'm just going to label all the sides. So this is 6, or negative 6, negative, or 6, 6, negative 6. And y equals 2x minus 5. Well, it's in slope-intercept form, right? And this would be the intercept, the y-intercept, and this is the slope. Negative 5 would be right here. And then we rise 2 and run 1. Rise 2, run 1, here, here, and here. And now we draw the line. Now for the second equation, y equals 1/3 of x, that would, the y-intercept would be like plus 0. Minus 0, same thing, you can't have a negative 0, so that would be like right here, right? And we go up 1, run 3. And then we go up 1, 1, 3. We do the same way, this same thing this side. Then we draw the line. So the solution of this system of linear equation is right here, right? And this point is 3, 1. And that is the solution for this system of linear equation. Now, let's do another problem. We have y equals x plus 3 and y equals negative 2x minus 2. Now here, y equals x plus 3, the slope is just 1, right? And so the y-intercept is positive 3, so that'd be right here. And then it's just 1, so we run up, rise 1, run 1, that'd be here, here. Draw a few dots this way, going to. And now we draw the line. Now we have y equals negative 2/3 x minus 2. The y-intercept being negative 2, so that'd be right here. And then we would go down 2, run 3, 2, run 3, and then this would be right here and right here. And now we draw the line. And the solution for this one would be right here, which is where the lines intersect. And this point right here is negative 3, 0. Now we have two equations which are not in slope-intercept form. Now, one way we could graph this equation is to put input for both of them and then just solve and then draw a line, or we could solve for the slope-intercept form. I'm going to solve for a slope-intercept form for both of them. So first, we need to isolate the y, so we're going to add 2x to both sides. So that'd be y equals y minus 2x plus 2x equals 4 plus 2x. And this would equal 0. So the slope-intercept form would be y equals 2x plus 4. Then for this one, it will be a little more difficult since this has a coefficient of 2 and not 1. So we're going to again add 2x to both sides, right? So that would be 2y minus 2x plus 2x equals 6 plus 2x. This would equal 0. Then that would be 2y equals 2x plus 2x, 2x plus 6, right? And then I'm going to divide both sides by 2, so 2x divided by 2 is just 1x, and then 6 divided by 2 is 3. So that'd be y equals x plus 3. Now we can graph both equations. So let's do this top one first. So the y-intercept is 4, and that is right here. And then we're gonna rise 2, run 1, that'd be here. And we're gonna do the opposite, which we go here. Now we draw the line. And now for the other one, y equals x plus 3, right? The slope, the y-intercept is 3, so that's right here. And then we go do this here, right? We go right now, we rise 1, 1, 3, 1. And now we draw the line. So right here would be the solution for this system of linear equations, and that is 2, negative 1, 2, sorry, negative 1, 2. Now that we have solved this problem, let's review. What did we learn today? We learned to solve a system of linear equations. First, graph the equations. The place where the lines intersect is the solution for the system of linear equations. That is all for this problem, so please put in the comments below what else you'd like to learn. I'll also be posting more videos with system of linear equations, so make sure you subscribe to my channel and check my other videos out. Bye!